Hey everyone, this is Dr. Walker. This is video 243. We're going to be dealing with RC circuits and specifically talking about discharging a capacitor. We've already seen this question in a previous video where I was asking how is it possible that a defibrillator provides a large shock that can stop fibrillation. And basically the defibrillator has a capacitor in there and it can release that energy very quickly and also in a controlled way when you combine that capacitor with a resistor within the circuit. So that is what an RC circuit is a circuit that contains resistors and capacitors. The values of R and C are going to determine how long it takes to charge or discharge the capacitor, which determines how quickly or how slowly that energy is going to be released. Let's look at the concept here, look at some pictures. So in the first picture, we have a charge capacitor is connected to a resistor. There's our capacitor. It's already been charged before being put into this circuit. There's an open switch. There's a resistor. When the switch is open, the capacitor cannot discharge because charges cannot flow through an open circuit. So this is just a charge capacitor connected to a resistor. Then we close the switch. Immediately after we close the switch, the capacitor starts to discharge. All of the charges here, if we think about positive charges moving, all the positive charges want to go all the way through the resistor, all the way to that negative terminal. So the capacitor starts to discharge. And I do have on this picture that when the capacitor is charged, there is initially a potential difference across it because there's two plates, one positive and one negative. Finally, the current decreases until the capacitor is fully charged. So all the charge is discharging until there's no more charge left on the capacitor to discharge. And then it's fully discharged. So that's the concept, just visualizing the charge just flowing away from that positive plate through the resistor towards a negative charge, discharging that capacitor. Let's look at some equations for this. The initial potential difference across the capacitor is V0, and it's given by Q max over C. So this comes from the equation for capacitance, which was the charge per voltage. So if you solve for V, for potential difference, you get Q over C. We're calling it V0 because it's the initial potential difference across the capacitor when it's fully charged. Therefore, it has its maximum charge. As it has less and less charge, the potential difference is going to be less and less. The initial current through the circuit, and this is as soon as the switch is closed, at the instant it is closed. The initial current is V0 over R. This comes from Ohm's law. The initial potential difference is V0, and the resistance in the circuit is given from our resistor over here. So these will be some useful equations for our initial values for a discharging capacitor. But what if we want to know, well, what happens after the switch has been closed for a little bit? How much current is there through the circuit? How much voltage is there across the capacitor? So for this, it actually requires calculus to derive these equations. So we're not going to derive these equations. We're just going to accept them basically. But these three equations tell us how the current, charge, and the voltage across the capacitor vary with time. So this parentheses time here doesn't mean that you're multiplying current by time. It means that the current is a function of time. The charge is a function of time. The voltage is a function of time. So how does current and all the other quantities depend on the time? Through this exponential function. It's a decaying function. There's a negative exponent here. What this function looks like is like this curve right here. So this is the curve for I versus t. So this is the curve I naught e to negative t over RC. But you could just pretend that this is a Q, and then it would be this curve. And if this was a V, it would be how the voltage varies with time. They all change with time the same way for a discharging capacitor. Okay, so the next video, we're going to do some examples with this so we can understand it a little bit better.